In Lab 17, all you're responsible for doing is filling out the worksheet and sending me a picture of it. But you can do the activity to receive bonus points. And what this activity simulates is fuses in your house. And I don't know if any of you have ever had a fuse blow in your house, but when a fuse blows, your lights go off. And that is to protect your house from catching fire, or from the wires catching fire. So what a fuse basically is, if you can see here on number 3, is you would put 2 pennies and one of the little steel wool wires, a very thin wire, in between the pennies in a small gap. So that's how you would build the fuse. So right here is what the fuse is. So number 5 is where you actually build the circuit, and you're going to have 2 batteries, and you'll want to use 2 so you can get enough juice pumping through. And your light bulb, then your fuse, and then your ribbon that completes the circuit, your wire that completes the circuit. So that's what your complete circuit would look like. And you can see all the electrons will have to pass through that little thin wire between the 2 pennies. And as we've learned in previous labs, that one of the hardest things for electrons to go through is the light bulb. And so, because it just has a very thin filament right here, a really thin wire for all the electrons to pass through. So it has a lot of resistance there. So the light bulb really slows it down by the time it reaches this other thin wire, the steel wool right here. But if we make a really fast surge in electricity where we bypass the bulb and we put a really nice, thick, strong wire right there, now the electrons aren't going to get slowed up by the bulb, and they're just going to go zoop really fast through here, and it's really going to overpower the wire in between the pennies. And that's why you see this little guy looking here, because that's what you'll want to watch, because you'll see once you put the ribbon across here, a little red melt, the wire will melt, it'll turn red and melt, or a little spark will happen right there, and the fuse will, what they call, blow, and it'll break the circuit. So then electricity would stop flowing through this circuit right here, because there would be a break right there in the electron flow, because that wire will melt. So the question you need to answer is, how does a fuse protect a house from a fire? Well, it stops when there's a huge electricity, a surge in electricity. It will just shut off, and so it'll just protect your wires from getting too hot and catching fire, because it just breaks the circuit. That's why it is a circuit breaker. So it breaks a circuit and it stops the electrons from flowing through and generating more heat. So that's how it protects your house from a fire. So the next question says, a fuse should be neither too weak nor too strong. So if you have a really weak wire, what's going to happen? Well, your fuse is going to burn all the time and keep burning out, and your circuit's going to keep breaking, and your lights are going to go out nonstop, and that's really going to drive you nuts. So you don't want your fuse wire to be too weak, or your lights are going to be constantly going out on you every time that circuit breaks. On the flip side of that, if your fuse is too strong, your fuse wire is too strong, it's never going to break, and therefore your wires can get really, really hot, and you're going to have a fire irregardless. So your fuse can't be too weak or too strong to truly protect your house from house fires and not drive you crazy in the process. So take a picture of your answers in Lab 17, turn that in, and do the bonus if you would like.